In my opinion, static typing is one of the most overrated features in programming language. I'm not saying that it's a bad thing. I'm not saying that it doesn't have value. I'm saying that it's overrated.
It can get very complicated. I would have an impression that someone, a person or a body, needs to keep or maintain the cohesiveness of the language, that it doesn't fall apart because of those different vectors, different people, these people pulling in this direction, these people pulling in this direction. And I would think that there might be a need to say, like, the direction is there.
What they have is that they have a bunch of Rails servers running in production. Requests are coming in. There is a spike. There are more requests coming in at the same time now. So they start a new instance. And then as soon as this instance is up, it starts serving a bunch of requests because they have a spike in traffic.
Right. And I'm wondering about the current trend with the AI-backed or augmented development, whether it would even make niche programming languages more niche because everyone converge on those most dominant.
Building a programming language is like kind of like a Jenga tower in the sense like I can remove this block. It's not like you remove that one thing or you change that one thing, right? And now the whole thing is crooked. So when you write the Python code that represents a neural network, and then you run that code, what the thing does is that it traces the Python execution, which methods were called. It builds a graph. I don't think like functional programming is a useful distinction for a programming language to have today.
Yeah.
Right? Like it's not really saying much.
We are up. It's a very great to have you here, Jose.
Yeah, thanks for having me.
Why don't we start with the Elixir? What else would we start with, right?
Yeah.
So we have 2026. How would you introduce the Elixir programming language in this day and age?
Oh, that's a very good question because I think it will depend a lot with the person that I'm talking to because Elixir is like it's a general programming language. It can be used for so many different things. So, and I think, like pinning it down to one thing in particular, it's going to be very hard. So I would probably like do some follow-up questions like, hey, are you a developer? Like, what do you work with? I think one of the things, so at this moment we are working on a new website for the language. And today, like, the slogan for the website, like the tagline for the language, I think it's like a language for like building scalable and maintainable applications or something like that, which is like very by the book. And some time ago I was talking to Tio, which is known famous streamer, and he came up with this slogan that we are going to put on the website some variation of it or it as is, which is simple at scale, which I think is like perfectly summarizes Elixir, is that it works at many different levels because it's a simple language that you can literally go from scale like to multiple cores, to multiple machines, to multiple GPUs. And the thing is that when you take any runtime, you can probably do that if you put enough work and effort. Like people talk a lot about scalability. Oh, does it scale or not? But scalability is not a binary thing. It's not 0 or 1, right? It's actually like a curve that is based on effort and on time. And Elixir is the simplest language for you to go, look, I have something and I want that thing to work at a massive scale. The amount of effort and cost you have to put into that is probably the smallest of all the languages and runtimes. So I think that's one way I could answer that question. It's like, well, it's a programming language that really embraces simplicity and allows you to apply it at different scales, right? But then depending on what you are doing, like I'm doing web, I'm doing embedded, I am doing like data processing, then I would have like a slightly different pitch.
Right.
Yeah.
Right. So that's an interesting angle because, like, to give you a background story, because we were supposed to have this conversation, a few weeks ago, I've started to rebuild some of the things that I built initially in, like, so with these, in the day and age of AI, it's very easy to to bootstrap a simple web app that does something that you need. So I've built a bunch of these applications over the last few months, and I started building them in Django, and there's the stack of Django, Stimulus on the front end, and with turbo links and things like that. And because we were supposed to have this conversation, I thought, like, why don't I build the next thing and maybe port something that I have already to Elixir and Phoenix? And what I realized is that the massive amount of things that I needed to create in Django and patch together were already sort of baked into the setup with Phoenix and Elixir. So there is also something, the angle of not only the scalability, but the ease of start, how neatly those things are connected together.
Yeah, and in my mind, those two things are related, because if you take any web app today, or what everybody say, like everybody's building agentic systems, right? All those things, what they are is, so if you're building an agentic system, those are a bunch of agents all running at the same time. So you need to have concurrency. It needs to be like a fundamental property of the language. But when you're running that in production, you are going to have some agents running on some machines, right? Which is basically things talking to OpenAI or Anthropic or whatever, right? So you have those things running on multiple machines, and then you have your users connected to different machines, and now you need to have the agent running on this machine talking to the user in this other machine, right? So now you have a distributed system.
Right.
And most other runtime is going to be like, oh, now you have to bring RabbitMQ or Amazon SQS. You have to bring something third party. But in Elixir, thanks to the Erlang virtual machine, that's a property of the language. Like, they can just talk to each other. Like, it's there. It's a part of the language. So you don't need to bring something else. You want to know what are the agents? So now you have all those things happening in the cluster. And you want to know which agents are working on this problem and which users are in conversation with those agents. Like, that's a feature that comes with Phoenix, right? So because the language was in the runtime, actually, right, was built to solve those problems. Exactly, like all those building blocks were elsewhere. When you're looking at those things, are like, oh, now I need to bring a queue management system. Now I need to bring a background job. Now I need to bring like a separate server or Amazon Lambda to deal all those things. It's just there, right? And it's not like additional abstractions on top. It's like, it's the same abstractions that you use to write every Elixir code. It's the same thing. And they just scale out without needing a rewrite. Like, so that's the other thing. Like, with most other runtimes, you can do that. Like, you can start working on your web app in most other runtimes, and they're like, oh, okay, this is working just fine. I built a chat app, right? But it only works on a single node. And then you're like, oh, wait, this thing needs to work across nodes. You have to rewrite that code. Like, you have to go bring the external job system, and then in the future, the requirements change again. You're like, oh, damn it. Now I have to maybe bring this other solution. So you're constantly rewriting. And in Elixir, it's the same abstractions. You just scale them out.
Right. And you have to rewrite. And even there is this burden of connecting all those things together that, as you said, it's becoming more and more difficult because you need to have all those things in your mind, right? I think it's especially difficult if someone new joins the projects and they realize, look, here I need to have this thing for this reason. There on the front-end side, I need to have these bunch of libraries. And what struck me was that with Phoenix and Elixir, you have all those things from the very beginning. So the learning curve, like the language is a bit, esoteric in a way for people.
It's different.
It's different, yeah. It's not that different for me. My background is from Scala programming language, so it's functional at least.
Yeah.
So it's sort of similar, but for many people it's a bit alien, right, at the very beginning. But apart from that, everything is neatly connected, which brings me to the question, what would be your design philosophy for the language/ecosystem, like the guiding principles that you have?
Yeah, so that's a very good question. Like, so when I started Elixir, it was about, the first proof of concept was 2011, but when I knew it was like, oh, I think this is going to go somewhere, was about like 2012, so 13, 14 years ago. And at that point, if you looked at like my competition, because that's that point in time, like from 2007, 2012, a lot of like new languages came up at that time. Like you had Go, Clojure. Scala is older than that, but that was the moment where Scala was starting to gain traction. Haskell was also older, and but started a lot of functional programming languages. That was the moment in time where they started getting a lot of attention, and then later you had Swift, F Sharp about the same time. So there are like a lot of languages coming up, and then if you look at a bunch of those languages, right, like my competition between quotes, right, is it was Go, which is like backed by Google, right, and then there was Rust, which was backed by Mozilla at the time, F Sharp for Microsoft, Swift from Apple. So if you think about it in terms of like, well, I want to create a programming language, I want to have it out there, and I want people to use it, right? And then if you look at those, like, well, what is the financial backing, the infrastructure they have behind them versus a language that at the time was coming from a company in Brazil where we're probably, 20, maybe 30 engineers. It doesn't compare. The scale is completely different.
Sure.
So my approach with Elixir at the beginning was, if I want this to work out, it needs to be a decentralized language in the sense that if people want to build something with the language, if they want to use it, and I think that's one of the reasons why you can use Elixir across so many different things. But like if people want to use it for web, if they want to use it for building embedded software, for doing like machine learning, they should be able to do that without requiring the language to change. They should not be like, oh, the language is not right, so now we need to go and do a proposal for the Elixir team to consider. Like all those things would slow, like, because it was clear, like it needs to be like a decentralized, like a general effort. Everybody should be able to throw their hats in and say like, look, I want to build on this language. I want to help the language grow. So that was my thought, like the language, of course, like there is a team that controls the language, but the language is extensible, and the development of the language is decentralized because a lot of Elixir is written in Elixir itself, which means that you can just make part of Elixir different or extend it to solve your particular problem, and everybody can just go and build all those different things.
Okay. So that is an interesting thing because you mentioned this competition. And I was thinking when you said that 2010, 2012, you coming from the background back then, from Ruby on Rails.
Yeah.
So, like, what made you to even consider this type of runtime and the ecosystem? Because it's like, it's not. It doesn't seem like the first choice or the second choice or even third choice for anyone to create a new language on. And just for the record, it's based on the Erlang VM /OTP ecosystem, which is I think for the regular, like for the average programmer, is completely alien, right?
Right. So, So the story, I'll try to make it quick, but so back in 2005, 2006, it was when everybody who was working with computers, web, you started to hear about multi-cores. Right? That was the moment where, you are going to buy a computer and then like, oh, this is a dual core computer.
Right.
And then like, what is a dual core, right? Like, because we never really mentioned like dual cores or quad cores before then. So that's when those discussions started to have. And that's when we started like in the Ruby ecosystem. And that's still a relevant discussion in Ruby, in the Python ecosystem, and many others, which is like, well, those runtimes, they were really designed to run on a single core, right? So if now you have a machine with 2 cores, how are you going to efficiently run your web server or your web app using both cores on the machine, right? And this is 2005, and today we are at a point where you have a wristwatch, and your wristwatch has quad cores, right?
Yeah,
so
things changed.
So this multi-core, at the time, like when we were talking about multi-cores, it was a faraway future, right? It clearly became reality, But that was where I was at the time. I started hearing people talking about, oh, how like we need to make everything run efficiently on all cores. And then I started learning about the global interpreter lock, that for runtimes like Ruby and Python, it just blocks everything when you go to the C code, and it doesn't allow you to do multiple operations at the same time. And then I was like, well, if everybody's talking about this multi-core thing, and if this thing is, so this is around 2010 now, and if this is going to be the future, there's probably a way of solving this problem. And at this point, I was already in the Rails core team, and I remember I got like a bug report. So that's like the bug report that changed my life, because I got a bug report from somebody saying, look, I have a Rails application running in production, and when we have a spike in traffic, the auto-scaling kicks in. And when auto-scaling kicks in, that new application fails to boot. And by the way, we are running it in multiple cores. So that was the report. It was a very detailed report, right? So if you think, so I was looking at that report, I was like, okay, so what was happening is this. So what they have is that they have a bunch of Rails servers running in production, requests are coming in, there is a spike. There are more requests coming in at the same time now. So they start a new instance, and then as soon as this instance is up, it starts serving a bunch of requests because they have a spike in traffic.
Right.
So that instance is now suddenly, while it's booting up, right, in the process of like warming up, because there are caches and things that you will slowly warm up as the requests start to come in. That application now, in that period of time, there is a race condition somewhere that makes it, when it's warming up, it's filling up the caches that make it so it cannot boot. Right? So it's a race condition. It's something that is happening because there are multiple cores, they have this application trying to use multiple cores, there's a race condition. When you get a bug report like this, you're like, okay, like first, how I'm going to reproduce this?
Yeah.
Because it's like...
Sounds like a nightmare.
Right,
Yeah.
it's very specific. And then how I'm going to reproduce this, how I'm going to isolate this, how I'm going to fix this, how I'm going to make sure the fix is correct, and how I'm going to make sure that there are no regressions, right? It's like...
Right.
it's a tricky one. So I was like, look, if multi-core is going to become the future, there needs to be an answer, right? Like maybe there is an answer somewhere. So I didn't start with the purpose of like, let me create a new programming language. I started with like, I just want to learn. I want to see if somebody has like solved this problem. So that was my initial goal. I'm going to learn. I'm going to learn different languages, whatever. It was not necessarily a language. Just want to see how this problem is solved. And that eventually led me to learn new programming languages. And I say like in this journey, there were two moments where it basically changed how I think about software. So the first one was when I found functional programming, which coincides with the time where all those functional programming languages were coming up. And today, like I kind of summarize it to immutability. Right? Because what you have in most programming languages today is that, well, if you have like an object or an array and you want to add an element to that array, you are going and mutating it in memory, right?
Sure.
So you go and you change the memory representation. So what happens if you have two threads now executing at the same time and they both try to change the same array, right? If they try at the same time, one can kind of like override each other, you can lose data, or in worst case scenario, get a segmentation fault and your whole server stops working, or you get undefined behavior, right? And functional programming, it was not because of concurrency, but functional programming comes with this idea of immutability. And the whole idea is, well, software is easier to understand if you're not just mutating things around. Like how many times when you're working on object-oriented language, you pass like an object to a function or call a method in a function, and it changes things like 3 or 4 degree level separations away, right? It's because immutability, like you change one thing, you call one thing, and that can propagate the change everywhere. And functional programming is like, no, things are going to be immutable. And then I was like, this is genius, because I'm coming here from the point of view of concurrency. And a lot of the issues we have with concurrency is that we are trying to have things change the same place in memory. But if you say, look, I'm not going to change things in memory anyway, the whole problem disappears.
Yeah.
Like, and for me, it's the proper way of solving a problem, because sometimes you have a problem,
Yeah.
and then you have a solution. So you have the problem exists, and then you have the solution on top.
Yeah.
So you need to deal with both still. But this, like, it just completely removes the problem. Like, the problem is gone. And I was like, this is fantastic. Like, this, like, it was like, it clicked very, very quickly for me. It was like, my software is going to be easier to scale. My software is going to be easier to understand. It was like immediate buy-in. And then I was like, okay, functional programming. That's it. I want to learn more. And then I learned Haskell. I learned Scala. I learned Erlang. And Erlang was the second part. When I learned Erlang was the second time I was like, okay, this like just completely changes everything. Because again, like in 2010, all those languages that were coming up, one of the reasons they were coming up is because they're like, we have a good concurrency story, right? Like Clojure has a good concurrency story. Right. Go has a good concurrency story. So they're all coming up at the time saying like, hey, we solved concurrency. But then there was Erlang, and Erlang was like, okay, we solved the concurrency problem, right? But imagine that you're writing a software and it doesn't, and you start using concurrency to use all the cores on your machine. But one machine is not enough. What is the next step? Now you need two machines, right? Yeah. Now you have a distributed problem. You have to have two machines working towards that solution. So Erlang was like, yeah, we solved the concurrency problem, but we also solved the next problem that nobody was talking about at the time, which is the distribution problem, right? And not only that, we solved both problems with the same abstraction.
And many years ago.
Yeah, and we solved it like 3 decades ago, yeah. Right? So I was like, okay, this for me was like, this is it. This is the runtime. This is the place where I want to write. I want to write my software on. If I'm building a system, if I'm building anything, this is the technology that I want. And I started using Erlang more and more. Built some prototypes for different things to get the feel for the language. And at some point, mostly as a learning exercise, I was like, okay, so I don't have a computer science background. I come from engineering. So I was like, okay, let me try to build something more serious. So I was like, well, why don't I try to build a programming language? Because then I can learn how programming languages work. I'm going to learn this platform in depth. And then I built a prototype that was really bad. And then at some point later, I was like, wait, I actually think there's something here. I actually think there is a programming language that can leverage the Erlang VM strengths and add new things on top. And I think it's going to be something that people will be interested and they would like to use.
And they did, apparently, at least to some degree. Which brings me to the next question. What is the popularity of the Elixir programming language these days? You see, and that's the one part of the question, that is, do you see it growing? It's going down? Did it stagnate?
It's so hard to measure popularity of programming languages because there are so many different ways of being installed, and developers, they are kind of averse to any sort of telemetry whatsoever. So, so when I look at, and because of AI now, what we would use as metrics is like no longer like very relevant. So one of the ranks that I was used to follow was the Red Monk. They were used to publish, right?
That's what we did too.
Yeah, but they stopped because, they had like 2 axes. One was Stack Overflow, the other one was GitHub. And what Stack Overflow, like now the metrics, they are no longer relevant. So the other one that I followed is like GitHub statistics. But the repository I follow, they have not been updated for 2 years. So, yeah, so I think like in terms of, so Elixir has, when you look at like GitHub metrics, like in terms of pull requests, commits, Elixir was between like top 20, top 30. So Sometimes it was below top 20, but that's kind of like where it fluctuates. But there is like, it's percentiles, like, like
Yeah.
Elixir is like 1.1. I'm coming up just with a number as an example, but Elixir would be like 1.1.15, and then the next one is 1.1.
Yeah.
Dot four, like sorry, 1.14, and the other is 1.15, which is it changes a lot. But
Right.
that's where it would put. I think if you would go like for the functional programming languages by some metrics, it would be like the most active in terms of functional programming languages, or it would certainly be in the top 3. But it's like it's just one angle, right? It's just like, well, it's activity on GitHub,
Yeah.
right? And how is market adoption? How is like jobs and those kind of things? And even that, it's kind of like when you have smaller communities, for example, which you probably see that with Scala as well. Like, yes, you can go to the big job markets, right, and see postings. But the companies that are active, they know that because the community is small, they're going to have a way better reach if
Yeah.
they go to where the community is, right? So even like those kind of metrics, they are a bit skewed, right? Because the community, when you are small, there are certain places where you can find more people, and those places end up being targeted. So yeah, it's long story short. I don't have really metrics per se in the sense of like like how does it really compare, or how where it is going, and so on. It's kind of like a black box in many ways.
Interesting. We sort of struggle with the same question because as a company being the stewards and the main commercial contributor, I guess, to Scala programming language and the ecosystem, we struggle with the same question. And it's difficult to say because
Yeah.
I think you are very right in that, there might be like 10 popular programming language that take a big part of the entire pie. And then you have the long tail of all those programming languages that you said. They differ in a really, in their decimal points in terms of adoption.
Yeah.
As one month is this, the other month is this. It's difficult to say. But we are interested in that, and because we are putting money in that, and we are trying to, on the 15 years in the market, we spent a lot of this time was spent, and we still are being marketed as the company behind the Scala or working in Scala and trying to push the ecosystem and doing the professional services. And I think that I'm wondering about the future of such niche programming languages, especially in 2026, when I have this feeling that one part of the story is what you mentioned. You said 2010, 2012, 2014, there was a bunch of new programming languages. So Rust, Golang, Kotlin, Scala a little bit earlier, but still around that time.
Julia.
Yeah. And those programming languages stopped to appear. I think that actually what happened is that the programming community in general, started to converge back on those dominant programming languages. And I'm wondering about the current trend with the AI-backed or augmented development, whether it would even make niche programming languages more niche because everyone converge on those most dominant ones. So I was wondering about your opinion about that.
So I have some thoughts on this. So one of the things that you were mentioning the company, just before we enter into the more AI specific stuff, it also up until 2020, we had a big consultancy in Brazil that was behind the language, and one of the metrics that we could use was clients, or people interested, which is, it's not reflective of the ecosystem, but it can be a very pragmatic way, right? But once again, it's very dependent on market trends, right? And not necessarily. So when we had COVID, I heard for a while that the first months was really hard on consultancies, but then the next year it was just fantastic, right? So you have all those external factors that may or may not be related to language adoption. And now coming to AI it's another big incognito. I like to say that from my point of view, I think building a programming language that that is going to be adopted, let's say that's going to get to the size of Elixir and Scala, which
Yeah.
even though it's like 1%, 2%, is like it's still massive
it's
in
still
terms.
massive. Yeah.
Yeah. Like for me, since I've created Elixir, I think it only became harder to create a successful programming language for some definition of success. Because so for example, when a Ruby or Python they came up, and Ruby they took a while to be like widely adopted. But it was like, look, you would announce it on Usenet, people would play with it, and people would start using it slowly. Like you would have small groups that would start like broadcasting, and it would grow from there. But I think today, because our tooling has improved so much and the ecosystems of programming languages in general have matured, like for people to be actively considering using your programming language, you no longer need a programming language, but you need the package manager, you need the documentation thing, you need the language server protocol. Because when I started Elixir, there was no language server protocol.
Sure.
It was kind of like every developer for themselves. They would write their bespoke integration with their editor. But now, if you don't have a good LSP, people will be like, "Oh, this is a hurdle on adoption," right?
Yeah.
So, and now AI adds this other thing, which is outside of our control, which is, well, will the coding agents be able to use it efficiently? And will the developers be able to integrate those developers who use AI as part of their day-to-day? If you come up with a new programming language, how well it's going to work? And there's always going to be like this chicken and egg issue, which is like, well, for AI to become better at this programming language, you need to have more software, you need to have more documentation written
Right.
on it. But if people are not using it, so for me, it's really hard to say. But my perspective on this, it's like it has become harder, I think, to break through. But it's like that's how I feel about it. I don't have any like data.
No, my feeling
Yeah.
is very much the same, but because it's when you pick up a language like Python or something like that, it's clearly seen that there's a bunch of libraries and bunch of tools that you need to combine together to get something that in many new languages is like, even if you take Golang, for instance, Golang is, I think, the extreme example. You got testing framework, you got linter, you got everything already included with the Golang installation,
Yeah.
which became the standard. And now, as you say, it's the LSP and things like that. So the bar is certainly higher. People expect from the languages a lot of different
Yeah.
tools. In the past, they might have released the compiler and that was it. And community
Yep.
go build all those tools. Right?
Yeah, no, I think Go is I think Go is also another great example, and I did not mention, but exactly like people want today like the language to come exactly with the whole tooling, with the whole
Yeah.
build tool, and Elixir mirrors that, right? So, but like the languages that came at the time or after, like Rust was not long after that it got Cargo, and now Cargo is like really part of the distribution. But yeah, everybody kind of knows, yeah, the whole tooling around it, the testing and the packaging to run in production and all those kind of things. Yeah, it needs to be part of the language as well. And you had the other question in there is like what AI means for those for upcoming languages or niche languages. And I think there are like some different points of view here. So one is well they're likely, so if you have a trend, right, it's likely, so, and the trend is Python being the most used programming language, or perhaps JavaScript, TypeScript, right?
Yeah.
One of the things people say is that, well, AI is probably just going to accelerate that trend.
So will that winner takes all sort of the characteristic?
Yeah, so that would be one perspective. The other one is that, well, if language does not matter because AI is going to be writing it, then it might as well be something that is better suitable for the job than rather than something popular.
Yeah.
Right? That could be another take into this. And I think there are ways, like in this whole thing that I'm saying, that creating a programming language only became harder. I think there's this opposite point of view, which is, well, now maybe, and I know this can be like a polemic topic, but so I wouldn't trust AI to do language design, but there are things that I'm very comfortable with trusting AI today. So maybe you can use AI to help close some of those gaps, right? So for example, so in Elixir, we have this project called Numerical Elixir, which is compiling Elixir to run on the GPUs, okay? So we create like the Numerical Elixir project. This was before LLMs.
So that's an X, right?
That's an X, yeah. And so, so we created a project. We have the framework for building neural networks. But now, each different model that you get they share some parts of the architecture. So if you have like a model and like an LLM or an AI model, it's two parts. It's the code that expresses that neural network and the parameters that make the ones that they are trained and shared, right? So we have the infrastructure to build all those things, but each model, or they reuse the architecture, or the architecture is like slightly different, like, oh, it's the same building blocks, but there is this component there is kind of different. And before AI, right, like if we wanted to build those, it's literally, well, we need to look at how this thing is implemented in Python and port that to Elixir. Right? But that particular activity, which like, look, I have this thing here written in Python, right? And I want to implement it in Elixir, and it's a direct translation. That's something that I would trust AI, right? Because it's a translation for something that it works. Plus, the neural networks, they are mathematical functions. Like if you give the same input, like, right? The same input, the same seed, you're going to get the same output.
You can build reliable test harness.
Yes, right? So you can just say, hey, if you get like Quen, for example, right? I can get the Python implementation, go to a coding agent, say, write the Elixir implementation using this framework. So it has a framework to do the building blocks, right? And make sure that it works. It's going to give me like a 95% good solution, right? It's going to be idiomatic. It's going to work because, right? So that's one of the things where we can look and say like, look, maybe AI can be a positive for new languages because there are new frameworks, because some of the things that we have to do, we can now just look at it and say, I want you to port this over. And I think this is in general going to work like really well for algorithms, which neural networks are, but also things like, you want to support HTTP3, you need to have quick, right? That's a pure thing. If you remove the socket bits away, the whole control flow, that's something that you can test, that's something that you can port and have a really good test to it. So I think in some ways, AI can kind of help level the differences between ecosystems. But yeah.
Interesting detour perhaps about the NX and neural networks. So you said that you could generate in a way sort of the implementation that would be 95% correct, and with some human touch maybe 100% correct. What would be about the performance, like comparing the NX implementation to the one from Python?
Yeah, no, that's a very good question. Yeah, so I think I would say that it's 100% correct because the numbers, they need to match, right?
Yeah.
So it's 100% correct, but the code may be like some code smells in the code, right? So the code would 95% good, and then you just need to review it, fix a couple things, like, oh, you missed this abstraction. But the performance, so here's the thing. I'm trying to see if I do the long version or the short version. I'll try to do a medium version. So if you think about it, they're like, and that was like that was my immediate reaction and a lot of people's immediate reaction. If you think about it, like a functional programming language is not going to be good for neural networks, right? Because if the data is immutable, so now you have like this huge matrix, right? and then you want to do an operation, you have to copy the whole huge matrix. That's not going to be efficient at all,
Yeah, well,
right?
part of it, there are the different data structures, but it's still tricky, right?
Yeah, right? But here's the thing. A lot of the fast programming of like a lot of the how the neural networks, the fast ones, the way they run, is that you implement the neural network like in Python. And what it does is that it has a trace. So when you write the Python code that represents a neural network, and then you run that code, what that thing does is that it traces the Python execution, which methods were called. It builds a graph. Then it gets that graph, compile it to the GPU, and run it in the GPU. So when you have like a neural network in Python and it's running, it's not actually running Python. So the Python is just a representation of the neural network that is then compiled and runs the GPU. Right. And it's really interesting because when I started getting to the neural network, like the modern neural network kind of things, like my thesis in 2010 was about like machine learning, but at the time neural networks, they were not like what they are today. But so when I started looking into in the last 5 years, 6 years, how like neural networks run, there's this project in Python which was a huge inspiration for Elixir called JAX, which comes from Google DeepMind. That's how Google does their machine learning stuff. And it's exactly this. Like you write some Python code that is going to be traced so it can build the program. But because it want to trace the execution, it has like some pitfalls in the documentation. So the JAX documentation, they say something like, when you're writing JAX code, you should think about it as if you're writing immutable programs, because you have to write it in a way they can trace it. Right? And they're like, oh, when you're writing JAX code, you cannot use conditionals because you cannot trace conditionals in Python. You have to use these different abstractions. So I was looking at that. I was like, wait. Like the documentation is saying, hey, when you're writing JAX code, you should think of it as if you're writing a functional program. And then I was like, wait, there is a programming language here that you don't have to pretend you're writing a functional program, right? And in Elixir, as we're saying, like at the beginning, because the goal is to be extensible, like if you write a conditional, you can actually get that conditional and compile it to run on the GPU. It's part of the language design. So I was looking at that. I was looking at their documentation of pitfalls, and I was like, we could actually address those pitfalls as like, if we have a solution in Elixir, we can actually provide something very similar to them and address those problems. So how fast it is, it's going to be pretty much as fast as Python. It's going to be the same because both of them, because in both cases, it's not Python or Elixir running, right? All you do is that you run Python and Elixir once to build that GPU graph thing. Then you send it to the GPU, and it's running on the GPU.
Got it.
And I think in many ways that's great because so we use like the same compiler as the Google JAX thing uses, like so the same infrastructure. That's why performance is going to be the same. And that's great because like those compilers, there is like so many hours, like thousands, probably tens of thousands of hours of work in those things that it would be impossible for us to replicate or reproduce. So wouldn't, like if we had to implement it, we would never be we would take a long time for us to say we are comparable with Python, right? So in a way that's great. But there is this other way where it's not great at all, in that there is really not a lot of advantage in switching, except for some problems, in switching from Python to Elixir. Because all they do is just to assemble code that runs on the GPU. So it's not like we can go Python developers and say like, hey, run it in Elixir because it's going to be faster, right? Or even like, like there is no like, there is just a very small aesthetic component of how you write the models, but beyond that, it's pretty much all the same.
Right. So it's an advantage for a shop that is already, Elixir, using Elixir.
Yes.
So for them, they don't need to have a different stack.
Yeah, so like that's part, and it suits really well with that story of Elixir. Like if you want to scale across cores, machines, or GPUs, right? If you're using Elixir and you want to stay within Elixir, you can do that very straightforward, right? Where in Python it would be like, in Python would actually not run the machine learning. most of the times you would not run the models in Python as well. You would like now bring a separate technology like tensor serving or NVIDIA serving to serve those things on a different machine. In Elixir, would be able to do the serving in Elixir as well. So it fits well, that simple at scale. But I think it's really hard for us to say like, well, like drop everything that you're doing in Python because of this particular advantage, because it's like when it comes to machine learning, right? I can go to Django and say, hey, you can drop Django and use Phoenix because you're going to be equally productive, but it's going to simplify a lot of the things that you do. I can talk about that advantage for web, but I think for machine learning, it's not there.
Right. Yeah, we had similar story, I think, with in the days with Spark, and when they introduced and they tried to promote Scala, which is, by the way, a big driving factor for Scala popularity back then. And there were many advantages, like this functional approach that was good for distributed data processing, things like that. And I think eventually what happened, because the other alternative was Python, was that I think Python was objectively worse in that kind of things. But the weird one is it's just had a bigger ecosystem. The gravity of the sheer number of people, libraries, and people focused on the Python made it that technically speaking, maybe Scala might be better for this particular, from purely from the technical perspective of the language.
Yeah.
But you know what? We all have all those tools, libraries, and people who already know Python, so it's just actually easier. And
And Spark itself went like through a similar process as machine learning, in that at some point what Spark was doing was not doing the operations. It was the same thing. You would like write the query.
Yeah.
It would just quill the query to send to an execution engine that would be in C and C++ or maybe in Java, right? And again, it goes back to the same thing, right? Like the front end language for those things is just really the front end for a compiler that is going to be.
It just happens. So functional programming languages tend to be better suited for building descriptions in general because of this immutability, because of these various structures that you have. These days, things changed because I think it went the other way around, that all the languages adopted over time the functional programming constructs and baked them into themselves.
Yeah, it's one of the. So I had recent discussions about this, which is like, what does it. Because, I mean, I don't think we are as fragmented as OO, but even like, what is functional programming really, right? And you cannot say that it's lambdas passing functions around, like first-class functions, because that would include Java, Ruby. Python has a very limited lambda, but like JavaScript, like, so that became to the point that when Java 8 came out and it had like lambdas, some people were saying, well, functional programming won in the sense that it became equally adopted, right? So you could use that as a definition, but then it's not really differentiating. Some other people would associate like functional programming to having like a Hindler-Milner or some sort of like a lambda-related type system is related to lambda calculus. So like I think like I've been saying this for maybe 2-3 years, that I don't think like functional programming is a useful distinction for a programming language to have today.
Yeah.
Right? Like it's not really saying much.
Sure.
Right? And that's why like with the website we write for Elixir that I mentioned, we are going with like simple at scale or simple from 0 to scale or something like that, to focus on other properties. Because then you also have things like, so to me, what attracted me to functional programming was immutability. And if you look at Rust has mutability, but the mutability is controlled in a way that I can get the same properties that the properties that I care about, like, hey, is this code mutating my things or not, right? Can I share this code across? Can I share this data structure across cores?
Yeah.
So I would not define it as a functional programming language, but the property that I care about, it's there.
Sure.
Right? And then they are like, Go and Rust, they really don't say that they are OO or functional programming language. That's not part of
Yeah.
their description at all. So yeah, so I think like it's an interesting thing like to talk about functional programming, especially like between the two of us
Right.
who probably like being part of functional programming communities for 15 years,
Yeah.
right? And my take is that like we kind of have to, at least for Elixir, I don't know how applicable it is for the others. Like we have to move past that. I think the label, the distinction was helpful when it was about, but I think now it doesn't add much, and we need to find other ways to differentiate ourselves.
Yeah, that's an interesting take. And by the way, the sort of the side note is that I think if we look into the roots of the object-oriented programming, there's also a lot about the immutability. It's just it never, like not never, but until 2010, 2015, where functional programming brought immutability back into the light. I think just the community forgot about those roots that was like the original assumptions were about message passing, things like that. There was a lot about immutability, and I think meta languages really, even in Java ecosystem, there were many ways how to add this immutability, and people knew, especially more experienced, that there is a value in immutability. I think it was just inconvenient in many ways, and that's what the functional programming language is at this convenience level, natural sort of the approach.
No, I agree. And I think it's worth saying that I think even before that, it was probably because we had more limited memory, but also in terms of research, we were like our data structures. Like part of the thing that helped with functional programming adoption was research that happened with Clojure and Scala about making like persistent data structures more efficient and faster and use less memory. So, and that was something that was happening within that period of time of 2005, 2010. Before that was kind of tricky. But the other thing also, like when it comes to OO, is that the languages that became like representative of OO, they had like this bag of features. Like they had polymorphism, they had inheritance. They had like the meta dispatch, like they had all those different properties, and it took a while for the programming community in general. I think like the academic community were able to quite early on, and I mean like in the 80s, in the 90s, to like see what is object orientation and break it apart into all of those different angles. Oh, this is inheritance, this is polymorphic dispatch, this is like they were able to break it apart, but for the programming community in general, it took a while for us to realize, wait,
Right.
it's not polymorphism is not something that only object-oriented languages can have, right? And then Go is a really good example of like, well, they have interfaces, right? But they don't have objects, so they got that polymorphic aspect. And so yeah, and I think that's something like this murkiness, and I'm not saying that as a negative thing, just the fact that when the innovation happened with so many things, that kind of, made it hard for us to recognize the values in different things, right? To the point that, took a while for, and I'm seeing like, so, I mean, so one of the classic, very old discussions is like on composition versus inheritance, right? And in the 90s, people were saying, nah, don't do inheritance. That's a bad idea. But it took a while for us to have a language. I mean, a language like Go, which is not FP, but saying, look, we have the polymorphism things, we have those properties without inheritance, and I think it's part of all this messiness that happen at the same time.
All right. Which brings me to another question. You gave me the opening by mentioning Hilner-Milner and the other things earlier about the typing.
Yeah.
And Elixir started as a dynamic programming language, and I know there is a movement right now towards these more static typing.
Yeah.
And I was wondering, what is your stand in this, discussion about dynamic versus static typing?
Oh,
So you're clearly not the enemy. Like if you ask, for instance, DHH, he was, I think, a few years ago, they built, it might have been Stimulus or something, I forgot, one of the JS library, and they completely removed the TypeScript. They started with TypeScript, with types, and
Yeah.
they came back like, we don't want types, like static types. We prefer JavaScript. It's way more elegant for us, and we can understand it better, whatever. It might be aesthetics, it might be something else, but that was their decision. So you've started with this dynamic approach, but now you are introducing more and more of the static typing. So.
Yeah. So in my opinion, static typing is one of the most overrated features in programming language. I'm not saying that it's a bad thing. I'm not saying that it doesn't have value. I'm saying that it's overrated.
It can get very complicated.
Yes. And what I mean by that is that people tend to attribute to static typing properties or features or benefits that are not really there. And it has, and the frustrating thing is that it has enough benefits of its own, right? But programmers in general, they tend to attribute more than actually is there. And I think, so my opinion is that static typing can bring enough benefits by itself to justify their worth without us overplaying the role that static typing has in a programming language. So, you hear like, so I constantly hear people saying like if I have a static typing, in statically typed languages, I can write fewer tests. And to me, it's like, I can't see that being a thing. Because so if that's the true, it means that you're writing like shitty tests. And I would argue that you can likely throw those tests out. Even today, you don't need static typing to tell you to throw those tests out because they are bad, right? Because all that the types are going to do is that they're going to say, well, for this set of values here, I can prove this function work for the set of values, right? But you do not prove anything about each particular value in there. So the example that I like to give is like, take like a Boolean OR, right? If you give true and true, it returns true. If you give true or false, true, false or true, true, false, false, returns false, right? The signature receives a Boolean, returns a Boolean. It doesn't tell anything about the logical behavior of that function, right? So if you only trust the types for like one of the most basic operations that you can have, right? The types are not going to give you the coverage and the property that you need. And by the same token, saying that, oh, well, this function, a test that asserts that function receives Booleans but does not assert the result of the Boolean is not useful, right? So,
fair enough.
So that's kind of like, so a lot of the discourse around types, I think, like kind of like overrate the benefit they get. And we hear a lot from people saying like, oh, types are your documentation, which is like, it's just, it's not possible to be true, right? So the reason I say that is not to be polemic, is because like as Elixir is in the process of adopting types, if the community out of that process comes out and say, oh, now we don't need to write documentation, we will actually make our software worse, right? So if we bring like those preconceptions that I don't think are true at all, like, oh, I can write fewer tests now because I have types. If the community starts doing that, we will have worse software. We will have gained types, but we lost something important. And that's why I bring it up. It's like there are clear benefits that types can give. Types can give performance. Types can be a form of documentation, but it's not the documentation. It is one form of documentation. Types can be a very quick feedback cycle when something breaks, right? And all those things, they're useful, right? But we need to be aware of what it's not giving us.
Right.
And the other thing is that every time we use all the statically typed languages, they constrain the developer. There's always the programmer like, well, I would like to write the program this way, but then you cannot make the type system happy, or you cannot figure out how to make the type system happy, and you have like to rewrite that code. So for example, I remember very clearly working on a project in Rust, and I could not figure out how to write a type signature for a function. So I implemented it as a macro. Because if I extract it to a function, now I need to define the signature, I need to pass like the lifetimes around and all those things. But if it's a macro, it's just injected code into the existing function, and then the type checker can figure it out. And it happens. Like as now I am in the process of like building the Elixir type system, I'm like, look, I won't be able to, because the type system, they're going to restrict which kind of code you can write. Right? You end up having all those things like, wait, I cannot build this abstraction this way, or I can only make this work with a macro, exactly because of all those limitations that are in place. And that's part of like, and so that's something that I'm trying to come to terms with, which is like, well, like the types, they're going to restrict the software that we can write. Right? And it's kind of like, it's like, so for example, they're like, I can write the code, so working, it's the same, I believe, for TypeScript, right? Or JavaScript, where you can write like the code in JavaScript. You can write tests, or I can write the code in Elixir. I can write tests, and I can prove that that code is correct, right? But if you want to write it typed, the code cannot exist because there is no way for me to add types because the type system is not expressive enough. Right? And that's something that for me, it's very backwards because you are and for me that's where the HH is coming from, which is like, look, I have this way where I think it's the best way to structure the software, is the way that I can make the software elegant, that I can make the software easy to read, easy to use, right? But because of a limitation of the type system, which all of them have, I cannot prove that thing to be correct. That code, that idea, that abstraction is not allowed to exist.
I mean, I'm coming from the background of Scala ecosystem, and I think that the type system is extremely expressive there. And you can do a lot of things with this type system. But it also means that if you try to do that, and that's my personal impression, is that you very quickly go into the area where it becomes the actual abuse because it's so difficult. It's so complex. Yes, you can edit code nearly whatever you want, but at what cost?
Yeah, exactly. And so it's like if you are thinking about trade-offs, right? Like there is, we can make the type system very expressive, but it comes with the downsides, as I said. Like we can write like those type signatures that nobody can understand. When there is a typing violation, the error message is huge and nobody can make progress, and that is frustrating. Or we can say we don't have types, and now you don't have types, and it means that there are bugs that could have been caught for free that are not being caught, right? So that's the process that we are doing with Elixir. With Elixir, we are adding the types behind the scenes. You don't write a type signature yet, and every release that we ship, we find bugs for free. Like developers, they don't change one single line of code, and we're like, this is a bug, or this is that code. And we know, like, it's proven, right? So if you don't use types, you are letting some things on the table, right? Like there are bugs that could have been caught that are not being caught, right? But if you say, look, I'm going to use types, I'm going to declare the type signatures, which is the JavaScript, TypeScript discussion, now there are things that you want to abstract and represent, where the type is like, no, I don't get it, and therefore you can't do it. And that's frustrating as well. So like looking at those three options, trying to figure out where I want to sit of those three is really hard, right? And for me, it's kind of exactly like going from dynamic to static, and not only that, actually doing research, like developing things, publishing papers, right? I think like I can have a good understanding of the different point of views that are there and why people prefer one or the other. And some people say like, like static languages can be as expressive as dynamic languages. Like that's just not true. Like we have like if you look at the research that we have published, like it's literally research developing new theory to type idioms that exist in Elixir, because up until like 2 years ago, that theory did not exist. So it's clearly dynamic code that was not typed before, and therefore is expressiveness that you could not have in static languages prior to this. Yeah, so it's very hard for me to figure out, and I think, and right now, so as I was saying, like the type system in Elixir, everything is happening behind the scenes. We have not touched the language, but I'll have to make that jump at some point where we'll have type signatures, right? And I'll have to decide and understand like where of those three different areas that we're talking about, like being fully dynamic, having expressive types, or having a limited type system, which of those frustrations are the ones that I want to deal as a person, and the ones that the community want to deal with as a community.
I think there are some studies that claim the number of bugs with the dynamic versus statically typed languages. And obviously they claim superiority of the statically typed languages, but I don't think those studies really take into account all the hassle that needed to be done during building the software. Like, sure, maybe because I can sort of imagine that if you have a very complicated type system and you eventually make it work, it's probably helps with some class of bugs.
Yep.
But the question is, how much longer did it take to really build it and wrestle with all the type system? Because for me, I'm not a great programmer. I'm some programmer. Probably, maybe average or above average, but not great programmer. And it is still awkward for me that after, nearly 10 years or 15 years of being close to Scala ecosystem, not writing the code all the time, but seeing it once in a while, at some period of my life building, a lot of code base, in some other periods of my life reviewing the code base. After all this time, I still cannot understand certain type signatures and how to build them.
And I think one of the things that we often don't recognize in those discussions is that there are all those different profiles of developers, right? So the HH for me, like he's clearly a developer for developers, right? He's building frameworks, he's building libraries, right? And I can completely understand his point of view where, because what he's doing is that he's building abstractions, the type system getting in the way of those abstractions is very frustrating, right? But then we have developers who are like, well, I'm working on this end user application, this business application, and the need for, let's say, like high level degree of abstraction of expressiveness is not necessary, and I'm completely fine with being limited by the type system, right? So and so I think like there's different profiles and the different kinds, the different things that we are building did not enter in those discussions, which is, for me, it's really funny, right? Like we just say like, oh, I am a programmer, right? But like, it's so different being like, for example, for me, like being a web developer to being like a type system researcher. Like both would fall under like, I am a programmer.
Yeah. Or a programmer in a big banking core system.
Yeah, or a type system implementer rather than researcher. But and whenever we have those discussions, we just treat it like, oh, we are all the same. And I don't think that's it's a good way to have those discussions. But yeah, you're right. Like, and then if you're building abstractions, and then you have those complex types, and those complex types, they all leak through to the end user, right? And now the end user is frustrating because the types are complex. Yeah, all those things, I think they are very hard. For me, they are like unsolved problems. Like, and I think, and most people tend to treat it as like no, this is a solved problem. This has been answered, and static types have won. And I think that's like, even if it was true, which I think I kind of hinted that I don't believe it's true and said why I don't think it's true, I think it's in general just like we have won. It's a kind of like a bad attitude to have. Sure. I think like there's always work to do in type system research. Even if you like, look, I am the static types, firmly on this static types thing. I think there's always research. There's always things that you can do to learn to help make it, how can we make the types more expressive without them becoming frustrating, as you're saying, right? Like, are there different ways, that different ideas that we should be exploring? And I think that part should, like, it should not stop,
Right.
right? It should always continue, right? Like, maybe in 10 years there's a type system that will make the HH happy, or people who are firmly on the dynamic side of things. It's just that it's not there. I can see why for some people it's not there.
Right. So where does it bring us in terms of introducing static type systems to Elixir? Because you didn't mention this name, but I think it's what you do is called the gradual type system. That's how would you call it? The
So
process.
we are building a gradual set theoretic type system, and gradual means that. So gradual, it's kind of hard to define, because when I say a gradual type system, people think about TypeScript. But it's gradual in some way, similar to TypeScript, but not the same. But gradual means that you can say that one type is dynamic, which means that you don't know what it is until you check it at runtime, or you cast it at some point on, if you check it at some point, right? And I had this discussion with a friend of mine, because like Rust has the any type, which is like the gradual type as well, right? And C# as well. Would you say that those languages are gradual just because they have this dynamic type, which is something that you don't know what it is until you force it to cast to something? So Elixir is a gradually type language, so it has this dynamic type, right? And it's important for us to be gradual because we are working really, really hard on making the type system understand as much of the Elixir code that exists today, right? We don't want the type system to be like, oh, you can't write that code, right? That would be bad. So most of our work of the research happening is to say, look, we can type like 95 of Elixir code right now, or some big number, right? We want to go really far, right? And then for the parts where we cannot do that, then we can say, oh, it's dynamic. That's a runtime behavior. You have to check later. But the thing that makes gradual confusing is because so historically, the way that gradual type works is that, if it's dynamic, one option that you can do is that if I don't know what it is, and then the user say this is a string, what you would do is that you would insert tests at runtime to make sure that that thing is a string. But that has a downside that it would make runtime slower, because now the gradual type checker is adding all those runtime checks, right? So that's one of the trade-offs that you can make with gradual, like introduce those runtime checks. The other trade-off, which is the one that TypeScript did, is that, well, you can say it's dynamic, and then at some point, maybe you're going to say it's a string, but we're not going to check. But what that means is that the type system say, oh, this is a string, but when you check it at runtime, is a Boolean. So it's not sound. The type system is telling you that the type is one thing, it's like a dynamic string or something like that, but when you check it at runtime, you get something else. So the type system is lying to you.
There's more of a like compilation hint or something like that, or a programmer hint during the while they look at the code, something like that. That's the purpose in that case?
The purpose of the type system in that case?
Yeah, in that case.
It's because even if in some cases it can be wrong, right? If in 95% of the case it's right, it can help you catch a bug,
yeah, fair enough.
right?
Yeah.
So for Elixir in particular, we developed new theory, which is like, it's now like a third option. It's like we do not make things slower, but we are not going to have like those wrong types. It's something that we call strong arrows. So we are doing like, it's a gradual typing, but we are doing like a different gradual typing. And in many of the other languages, it's like in some of the other gradual type systems, if you have something that is dynamic, and then you use it as a string in some place, and then you use it as a Boolean elsewhere, the type system's like, it's cool. You know it's going to fail.
Yeah.
But because the way the dynamics implement the type system, it cannot say anything, right? But in Elixir, even though we have the dynamic, we have the gradual type, if we use it as a string and then just later use it as a Boolean, we are going to catch a violation. So we did like, we have a gradual type system in the sense like, it's a gradual type system, but we have made different trade-offs and we are exploring different approaches that I don't think have been tried at scale before. I'm not going to say it's better because we have to try it at scale. It's being actively researched, it's being actively implemented. But we are working on Elixir 1.20 now, and the release candidate's out, and we are type checking huge amount. Like we type check code bases with millions of lines of Elixir code, right? And the type system is fast, is finding bugs, right? So we are slowly getting there. So that's one of the things. It's gradual, and the other part it's easier, luckily, to explain. It's a set theoretic type system, which means the whole foundation of the type system is built on set operations like unions, intersections, negations. And that's what brings a lot of the expressiveness to the type system. Is that, and for me, I love it because it's fundamental operations, right? It's like you learn maybe fifth grade,
Yeah.
right? And the type system is built on that, and you can use the same thing to reason about the software. So for me, I really enjoy that part and just bringing set reasoning to code and types, and hopefully that is going to allow us to be expressive without being daunting, right? Without, yeah.
So it sounds like it's gonna be a longer story in general.
Oh, it is a long story. I think we started in 2021.
Right.
Yeah, so we already had Guillaume Duboc. So I've been working on this with Giuseppe Castagna, which is a researcher. He's a very known and respected researcher in the field of type systems and type theory. He has a bunch of papers. And so he's the researcher, and then we had a PhD student. So he worked for 4 years in his PhD, and he just got a PhD like last month. And it's 4 years, and it's and I think we have now three or four different research projects happening right now on typing different parts or different aspects of Elixir, or even on something simple like research on having really good error messages. So it is definitely a long-term effort, and I have been very careful with this, right? So that's how I said 2 times already, right now everything is just running behind the scenes. We run on your code, we find bugs that we are certain that exist, and then slowly with time we are going to ramp up the amount of type checks that we do.
So that's a big thing. And besides the introduction of the type system, a static type system or a gradual type system, what are the other big things that you as not specifically yourself, but the community behind the Elixir, what do you envision are the big things coming to Elixir in the next few releases?
On Elixir itself, I mean the community.
Huh.
Perhaps both.
Yeah.
Yeah. So that's one of the things. Sometimes people come to me and they ask "Oh, what do you think I should work on for Elixir?" And my answer is don't ask me, ask yourself. Kind of like a Buddhist monk kind of answer, because going back to this Elixir being decentralized, it's the community should make it happen. So in a way, we have all those things like machine learning happening in Elixir, data exploration, we have multimedia processing, we have some recent work on compiling Erlang rather to WebAssembly and running WebAssembly. I don't know if I said machine learning, web development. So we have all those things happening, and they are embedded systems. They are let's say sub communities within Elixir that are shipping and doing their stuff, right? Yeah, and I know that they're all working on different and exciting things and improving in their respective medium, and I wouldn't be able to tell you much more beyond that, right? And for Elixir itself, the effort has been on the type system. That's what I have been focused on. That's what I've been focused on. That's what I've been spending most of my time. And but Elixir is like, it's a very stable language. Like, there are very few changes coming to the language itself. Like, every release is pretty much like, we made the compiler faster, we added some convenience functions, and we improved the amount of type checking that we do. That's like the last 4 releases for the last like 2-3 years.
Yeah.
And I don't see that changing.
Right.
It goes back, we can kind of wrap this all up. It goes back to the, like, the language was designed to be extensible. So people should be able to do things that they want to do without changing the language. And that has reduced, that combined with the fact that we are running on the Erlang virtual machine, which, as we said, has at this point, 4 decades ago, came up with innovative ideas that other ecosystems still do not have. I think that combination of like this extremely powerful runtime with the extensible language puts us in this very comfortable spot where the language does not need to be changing quickly. And things like, we always improving the tooling, so like the language server integration, this kind of stuff. Right? So it's mostly like tooling, compiler, type system focus.
Yeah. Part of it, I think, was related, in my mind, maybe that's a question actually. It seems to me that part of it, the fact that you don't feel that there is a need for change in the language itself, comes from the fact that I mentioned at the very beginning, Elixir might seem alien to someone who is not used to functional programming. But actually, when you get into it, the surface area of the language is relatively small.
Yes.
There are a few contracts, and there is nothing that would surprise you. And I think that maybe part of the complexity that comes in other languages that are still being actively developed, even though they are already at least they have as many years as Elixir or even more, is that static typing brings a lot of complexities that need to be dealt with. And given that Elixir in the current form, at least for the for the programmer, it doesn't have these static typing, it makes things simpler, it makes the language complete as it is.
I think that's an interesting point, and I think I can. So I definitely agree with certain ways. I'm trying to see if there are points where I would disagree with that, like counterexamples. I can definitely think of examples, exactly as I was saying, like, because you can, like, all type systems, they are going to reject valid programs because you cannot prove to the type system. So it means that often you need to come up with abstractions just to please the type system, or you need to develop the type system to make it work with certain cases. Some time ago, somebody asked to add like a new function to Elixir's like standard library. And now that we are in the process of adding types, I'm starting to think myself, well, if we add this new function, can we actually have a type for it? And then I spent a day on the problem, right? And I was like, no, with the type system that we have, we wouldn't be able to provide like a proper type for this. And then it means that one direct consequence of this is that the only way we could implement this, let me give a step back. So when we think about a type system, there are actually 2 levels. So one are the type signatures that we can put in the functions, right? So if you can put a type signature in a function, it means that you can express that code within a type signature and it's going to work. Like, you can type that function, right? But the type system itself, it's actually a superset of what you can put in function signatures. So there are things that the type system can do, but we do not know in terms of type theory how to represent that in a type signature. So we usually call those things type operators. So those are things that it can only be implemented as part of the type system. So as going back to the example, so Wojtek, he is a friend of mine. We work together. He's the one who sent the PR to add this new function. And this new function, I could not add a type signature for it. But if in the type system, I went there like, oh, when the user is calling this function, this is what it means, and I kind of implemented by hand what it means, it would work. And you can see now how that clearly impacts the language's extensibility.
Yeah.
Because now it means that for certain things to exist, it can only be done if added to the type system and
Right.
changing the type system and changing the language,
Yeah.
right? So that's one of the points where I'm like, yeah, I agree with this. Like the type system is going to restrict the amount of programs, is going to restrict abstractions, which is if you really want something, sometimes you may need a language to change, and that's the only way forward.
Interesting times ahead in that case, because the type system in one way or the other, as you mentioned, will come into the Elixir ecosystem. So we'll see how it will affect the complexity and things like that. But yeah, having my fingers crossed for you figuring out the ways how to make it in such a way that is as unobtrusive as possible, right? It definitely would be something novel. Is there anything from the next year, depending how we count, Elixir is going to be 15 years old, something like that?
Depending on how you count is a good one. Like I think we kind of have like two kind of birthday dates. So one
Really?
is the first. I think most languages. One is like because the repository was always like since my first commit. Don't look at the first commit and the commits. Don't look at the first 100 commits. But it has always been public. But like the Elixir that was the Elixir that we use today, like it's not the exact same, but pretty close. Like it's from like May 2012. So yeah, so like the first public release of something that slightly resembles Elixir.
It might not have been a hell of a lot of time, but it is some time,
You mean like typing the release of the type system with the...
No, I'm like not necessarily the time that you spent on building the language and the time that the language, the gathering community around that. So my question was: is there anything in particular in the language design that you regret, or you would do differently, if you were to do it again?
Oh, there's definitely something. It's embarrassing because I'm asked it a lot and I never have an answer, and I should just write it down. And I think, and it was even last week, I think I was working on something and I was like, this would be, I was like, this would be a good answer or something that I would change when somebody next asks me the question, but I can never recall on the spot. But there are definitely things that I would have changed. Yeah. But it for me, it's like, it's such a hard question. Because I'd say like building a programming language is like kind of like a Jenga tower in the sense like I can remove this block. It's not like you remove that one thing or you change that one thing, right? And now the whole thing is crooked.
Yeah.
Right? So it's very tricky to so maybe even when I think about like those things like I don't do it as often, but in the time I was like, oh, should I have like designed this feature differently? Then I go in this a rabbit hole where I'm like, well, but then this would have to change, and this would have to change, and this would be different. But that one is so good that maybe I wouldn't change it,
Right.
And yeah, I think. But the other thing is like when there's something that we are like really like, oh, this was a bad idea. We deprecate it. We keep it in the language. It's just deprecated. When we have a reasonably sized list of deprecations.
So when do you remove the deprecation? You remove them at some point after several releases?
No, so Elixir is we released 1.0 in 2014 and it's still 1.20. We never had. I mean, I'm not going to say we never had breaking changes. Sometimes you do fix a bug or something
So it happened by accident.
Yeah, but we have not like, look, we have removed this thing
Right.
from the language. It can be like, look, we fixed this bug and now you have to update your code in some cases, right? But since then, my goal is that if one day we release Elixir, especially now with the type system, because with the type system, we are going... So what we have been doing so far is that, look, this... We cannot type this, we'll be like, we'll figure out how to type this, right? That's what we have been doing. But it's clear that after we're done with this process, there are going to be a lot of things that are going to look at this like, well, we can't type this, and then we'll have to say we can't type this, and it's a shame because this is really good and we should be able to type it, or we can't type this, but it's a bad API, or this is a bad practice, and we want to deprecate. So my goal, let's say, for the next 3 to 5 years is, as we continue adding the type system, those things that we consider to be bad, or for some reason we can't type and we have to regrettably say like, oh, maybe we should move to some other abstraction, they are going to be deprecated. And Elixir 2.0, if we have it, when we have it, would be the same as the latest 1.0 version, except the deprecated features. Which means that, this is ideal in my head, right? Which means that if you run elixir.x that we'll have at the time, and you don't get a single deprecation warning while you compile or while you run your tests to it, then it means you can upgrade to 2.0 with no breaking changes whatsoever. It should just work.
Wow.
That's the goal in my head. Like maybe we are going to have like one breaking change here and there, but minor.
Right.
Like I think like in the issues tracker we have 2 things, which for us is like we are listing as a breaking change, but they are like extremely minor. I would say less than 1% of the project
So what you're
would be
saying
affected.
is if I picked up the code base from maybe 2015, which might have been running on Elixir 1 something, single digit number, there's a fair chance that it would run
Yep.
with the 1.20.
Yeah. So you know what is the
That is amazing, by the way.
Yeah, but you know what is the ironic part? So like I maintain many libraries, and those libraries they have the Elixir requirement, like Elixir 1.7 that was released like what, like maybe 10 years ago or 8 years ago, let's say. And I have to bump the Elixir requirement. And you know why I have to bump the Elixir requirement on those packages? Because there is no Ubuntu version with that Elixir version anymore. So like most use GitHub Actions, right?
Yeah.
So when they deprecate like the old Ubuntu versions, then it forces me to upgrade Elixir. So like the deprecation of Ubuntu is faster than the deprecation of Elixir. And then of course I could go, but then like the Ubuntu release eventually goes end of life anyway, right? But it's most often those things that get in the way of you like running Elixir version. So if you're using the Phoenix Web Framework, most of the time, because you can't scrape from JavaScript if you want to have like some client-side code, when I get an old Elixir project, the thing that makes it hard for me to run that project is always Node. So when Phoenix migrated to ES Build maybe 4 or 5 years ago, it was fantastic because ES Build is just beautifully stable. It's stable as Elixir. But yeah, like the language itself has been extremely stable.
Coming back to this community part, you don't believe in this benevolent dictator for life?
No. I mean...
And I'm asking this to give you a background on this, a little bit more of a context. I sort of see how it's an interesting, approach. You saying, work on whatever you think for the contributors, whatever you think is interesting or important. But on the other hand, I would have an impression that someone, a person or a body, needs to keep or maintain the cohesiveness of the language, that it doesn't fall apart because of those different vectors, different people, these people pulling in this direction, these people pulling in this direction.
Yeah, so I think you need to have a team, right? And even for with this benevolent dictator thing, I think I very much fit into the description, because who decides even though there is a team, most of the decision of where the language is going and what is happening, it's coming from me. I think like and if it was not coming from me, it would be a small team of people that the community trusts, right? So I believe in that model. But yeah, I have issues with the more with the for life aspect of things, right? As you can kind of get
Okay.
from this conversation, I actually would do my best so people do not depend on me, right? I think that's kind of my responsibility. It's like, people should not depend on me. Like we should, like this is a this is a language for writing concurrent systems. We should remove any sort of single bottleneck, single sort
Yeah.
of dependency point, right? Both in the language and in the organization itself. But I think like if you're doing something like a type system that like at the very beginning of the language, you definitely I think need a strong hand or somebody who's going to be strong-handed about that design. When you're working on a project like the type system right now that is very encompassing of everything, I think you do need like a strong hand that is going to dictate that and have this vision that is going to allow it to go through. But yeah, like ideally, at some point I'll be like, all right, I'm out, right? And I think I did my job. I think it's stable. I think it's the language we wanted, or at least I wanted, but hopefully we as a community wanted to have, and it's in your hands, right? So at some point that transfer is going to happen. I don't think it's now, right? But maybe in the next 5 to 10 years, it can happen, right? When I feel like I'm done with the type system, what had to be done there, it's over. That's probably like my last biggest Elixir project. I don't want to make anybody scared, right? Because as we saw, it's a very long project.
Yeah.
There
You
is
need to
still
be careful what you say publicly.
yeah. I don't want to, and of course, I'm not just going to be like, nope, I'm
Yeah.
out, right?
Yeah.
There's going to be a slow transition. I'm probably going to still be around, give guidance, but I think all communities, right? I don't think that should be something that communities they should be afraid of. I think it's a sign, like being able to do that transition, is a sign of a healthy community, right? Of a health project. Yeah.
You still have enough hours in the day to take care of all the projects that you are working on?
Yeah. It's I was used to say jokingly that I wanted to kind of retire at 40, not like retire and like now I'm going to go like take care of my own farm kind of thing, but like retire like because there's like this part that we haven't talked about that of being a public persona that is extremely exhausting, right? And that's what I mean, right? Like I would love to retire the public persona at some point, right? That like I mean I enjoy, right? Like I enjoy coming here, having those conversations. I am a geek in terms of like coding. I love talking about those things. I love having those conversations, but having this concern of like, well, what I like. So for example, I just said that I want to retire at some point, but I don't want people to be worried, right?
Yeah.
That's that concern right there is a very good example of like being this public persona and having to be careful about things that I say, because understandably that has an impact on people's lives, that has an impact on people's job and the company that makes a decision to adopt Elixir. That's all very fair and understandable, but it's also very fair and understandable that that's a tiring process, having that
I can imagine, yeah.
that responsibility. So yeah.
All right. Listen, so it was very great to have you here, and it was an extremely interesting conversation. So we have few more topics to discuss about, but we can do them we can discuss them in our next episode.
Sounds great.
Thank you very much.
Thank you.